Ladies and gentlemen, fellow competitors and esteemed judges, Europe's future power system, what will it look like? A couple of months ago I travelled to Red Electrica, the grid company of Spain. I was attending a workshop of Europe's grid companies, and this question was hot on the agenda, with everybody having something to say. You see, grid companies across Europe, including EirGrid here in Ireland, are presently undergoing fundamental transitions to sustainability and experiencing groundbreaking changes in how they operate their power systems day to day. And as we move into the future, that transition is set to explode on a much larger scale. Europe as a whole is on a mission to transform its energy system. To achieve its ambitious targets in the future, it will need to completely decarbonise its energy mix. So what do I mean when I talk about decarbonising our energy system? I'm talking about getting rid of the fossil fuels that exist on the grid today, your oil, your coal, your gas, and replacing them with renewable forms of power, so your wind power, solar power, all of these fuel sources which will light up our future power system. Now, of course, all of this new renewable power is likely to be remote from existing load centres or large cities across Europe. Most of it may be offshore. And therefore, alongside all of this new renewable power, we'll also need to build lots of new grid infrastructure. So you're probably sitting there a little sceptical right now, thinking to yourself, why the need for all of this grid infrastructure? The lights are on. Aren't we doing just fine the way things are? And that brings me to the next question. Why? Now, it's globally recognised that climate change is one of the biggest challenges facing the world today. Increasing greenhouse gas emissions, rising fuel prices, uncertainty over our rising global temperatures, and perhaps the election of Mr. Trump as President of the US, are all factors leading to the need for Europe to transform its energy system into the future. Coupled with this, it's globally recognised that in the coming years, as we move towards 2050, the role of electricity in the heating and transport sectors is likely to soar. For example, the electricity used to power our public transport here in Dublin. In fact, one study suggests that by 2050, a 30% drop in electricity use due to energy efficiency measures will be completely offset by the rise in electricity in the heat and transport sectors. Put simply, our future AC grids across Europe will be unsuitable or unprepared for this massive transition to sustainable power that's ahead of us. The big challenge facing Europe is, do we stick with our traditional point-to-point model of connecting new renewable power onto the grid? Or would Europe's future power system needs be better served by a multi-interconnected model? And the growing emerging consensus is that our future power system needs would be better served by option B. And all of this knowledge gained during a short business trip to Spain. You see, it wasn't a business junket after all. This is an interesting and challenging engineering problem, and it must be solved. And I think I might have found the solution. I'd like to introduce the supergrid as the future power system that would enable Europe to undertake that transition to sustainability. You'll see on screen large amounts of solar power in the south of the continent, combined with large-scale wind offshore and hydropower further north, which combines together into one large multi-interconnected model that would enable Europe to undertake that transition to a sustainable future. So I've set the scene. I've talked about the what, the why, and the how of how Europe might transition to that sustainable future. I'd now like to put it into practice for you a little and maybe outline a little bit more of the engineering detail or design. So on screen what I've shown you is a geographical map representation of what phase 1 of supergrid might look like. And this is the basis of a larger study I undertook during my time at University College Cork. So this is what phase 1 between Ireland and the UK power grids might look like. You'll see the presence of a large super node on the southeast coast of Ireland. And the idea would be for large clusters of renewable power, a combination of on and offshore resources, combining together at this central point for onward transmission across Europe. To zoom in a little bit on the supernode itself, and supernode is a combination of AC and DC technology. AC, alternating current, is the type of current power that we have on the existing grid today. And it would be the basis for large amounts of renewable power to all collate and travel into one central point, this supernode. From here, it would then be converted from AC to DC power at a large substation before it's transmitted onwards into the UK and further afield. Now, of course, the choice of HVDC or high voltage direct current for the large distance transmission is deliberate in this case. You see, with increasing distances in an AC cable, more and more equipment is required along the cable to compensate for the reactive power requirement within that line. You'll note the presence of these static series capacitors here on the graph. So what I'm representing here is the increasing transmission distance on the horizontal axis. And as the AC cable gets longer, more and more of this compensation is required, which increases the cost. DC, on the other hand, although requiring this expensive terminal equipment on either end of the cable, becomes the more economic solution at a certain distance. And in the case of my study, the distance was about 100 kilometers. Now, the technology that would enable supergrid and supernode to happen is primarily based on technology that exists across Europe today. The method by which we convert the power from AC to DC is based on voltage source conversion, which was a technology pioneered by the grid company ABB 20 years ago. So your alternating current would come into your supergrid, pass through a rectifier to convert it from AC to DC. It would then flow undersea across Europe to another supernode on the other end, at which point it would pass through a rectifier to convert it back from DC to AC power so that it could feed into existing grids in those countries. Back in Madrid, the closing sentiment of the workshop was that no matter what solution is chosen, collaboration will be key. And in my mind at least, collaboration is all about identifying, brainstorming, and exploring possible solutions, and then presenting those possible solutions. What I've shown tonight is just one of the many solutions for Europe's power system that may enable us to take that transition to sustainability. As Isaac Newton once said, if we can see clearly into the future, then we're standing on the shoulders of giants. So will this be the transition that breakthroughs and fulfills our transition to sustainability? You can cast your vote at the end. Thank you very much.